Example 2. Example 2. Find the component form and magnitude of the vector v that has initial point 4, -7 and terminal point -1, 5. Now, if we do a quick sketch of this, so 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So here is our initial point. And then the terminal point is -1, 5. 1, 2, 3, 4, 5. So we're starting here, we're going to here, and it looks like this. And what do they want us to find? They ask us to find, to write it in the component form, and they ask us to find the magnitude. Okay, so let's do that. So remember that our point, our initial point P, this is going to give me my P1 and my P2. My terminal point Q is going to give me my Q1 and my Q2. This is P1, this is P2, this is Q1, this is Q2. Now, in order to get my components, V1 and V2, remember that I'm going to take for V1, Q1 minus P1. In other words, I'm going to subtract my X's. And in order to get V2, I'm going to subtract my Y's. So that's what we did here and here. Here I have V1 is -5 and V2 is 12. So if I were to write it in this format, I would say V, and this is -5 and 12. This is our component form. Now, the other thing they asked us to find was the magnitude. Remember that the magnitude, and it's written two ways here. Let's focus on this top one, and then I'll show you the more detailed one on the bottom. So the magnitude is going to take these values, V1 and V2, or V1 and V2, and we're going to put those into that distance formula. Now, the reason it doesn't look like distance formula is that we already subtracted these 2 points out. We already subtracted these. And so we got -5. -5 squared is 25, plus 12 squared is 144. 25 and 144 is 169, and the square root of 169 is 13. Let's look at a more detailed version of it. So here I've written it so that you actually see all of the steps. This starts from the initial 2 points. But you'll notice that once I get to this second step, I'm here already. And I get the same answer, 13.